So in this question, here's an interesting question. A tunnel is dug along the diameter of the earth, and we need to show that the earth can be assumed to be a solid sphere of uniform density, and we have to show that a particle, when released inside the earth in this tunnel, executes a simple harmonic motion, and we also need to find out the time period of the simple harmonic motion. So we have a standard way and a fixed way of proving that whether a particular motion is SHM or not. You have to use this method in all the questions of proving SHM. So in the method is, you find out the equilibrium position, you displace the object from the equilibrium position by a displacement x, and then you find out the restoring force, that is equal to force that is bringing the object back towards the equilibrium position, and that restoring force, if you find out that restoring force to be directly proportional to the displacement x from the equilibrium position, then you can say that the object is performing SHM. So we go about with this method to get, this is a tunnel along the diameter of the earth, this is the equilibrium position of the particle. We first found out the equilibrium position. Now let us displace the particle from the equilibrium position by a distance x upwards. We can do it for downwards also, there is no problem in that. So we need to find out the restoring force. Let this be the restoring force FRE. We need to find out the restoring force, that is the force which is bringing this particle back to the equilibrium position. So this restoring force is the net gravitational force due to the earth on this particle when it is at a distance x from the center along this tunnel. So this force can be found out by at a displacement x, let us draw a sphere of radius x. Now we can safely say that for all the particles or for all the mass which is outside this sphere of radius x, the net gravitational force due to this whole mass on this particle is 0, because this whole mass can be distributed into thin spherical shells, and due to each of the thin spherical shell of uniformly distributed mass, the net gravitational force at this point is 0. Therefore, due to this whole mass, the gravitational force at this point is 0. So the gravitational force at a distance x from the center is only because of a sphere of radius x. Now let us first find out the mass and radius of the earth are given. Now let us first find out the mass of this sphere of radius x. Now the mass m dash upon mass of the earth will be equal to 4/3 pi x cube upon 4/3 pi r cube. Now this term gets cancelled. We get m dash is equal to x cube upon r cube into m. So this is the mass of sphere of radius x. Now x cube upon r cube into capital M. This was m dash. Now the total force, we need to find out the total force on this particle kept at a distance x due to a sphere of radius x. Now we know that for all points on or outside the surface of the sphere can be assumed to be a point mass kept at its center. So for finding out the force due to this whole sphere on this particle, we assume this whole sphere to be kept at its center. So the total mass kept at the center becomes m dash. So the force on this particle of mass m kept over here comes out to be g into m dash upon x square. So the restoring force is, and this force is attractive in nature and acts towards the center of the earth. So this restoring force is equal to gm m dash upon x square is equal to gm upon x square into m dash. We feed in the value of m dash over here to get m into x cube upon r cube. This gets cancelled to give x. So this becomes gm m x upon r cube. So we now see that the restoring force is directly proportional to x. This is in the format F restoring is equal to kx. Mind you, the formula for SHM is F is equal to minus kx, but the minus sign only tells you the direction, that whenever the displacement is from the equilibrium position in the right direction, the minus sign tells you that it will bring you back to the equilibrium position. So we have already taken into mind the direction here, that when the displacement x is in the upward direction, the attractive force is in this direction. When the displacement x is in the downward direction, the attractive force is in the upward direction. That is, the force is definitely restoring in nature. And so we now need to only ensure that it is equal to a format k into x, that we have already got here. So we get the value of k is equal to GMM upon r cube. So we have already proved that this is SHM because the restoring force is directly proportional to x. Now the time period of SHM is equal to 2 pi root over m upon k. So that is equal to 2 pi root over m upon, the value of k is this, we feed in here GM m upon r cube, m gets cancelled. So this is equal to 2 pi root over r cube upon GM. So final answer for the time period of the SHM comes out to be 2 pi root over r cube upon GM.